Hello guys and welcome back. So as we had discussed in previous session, we had seen there the graphical representation in the quantitative methods. So extending that session, now we do have, apart from graphical representation, we also have the distribution form of representation. So what is mean of distribution form of representation? Okay, so let me tell you guys, the distribution, it is been used when there is a scenario where you want to represent some data in set format. That mean the data in range format. For example, I want to find out, for example, we have a school. Okay, I'm taking it as a maybe BCom student. This is class of BCom graduates, where for example I have to show the result for any specific subject. Okay, so how I can do that, let me tell you. So I'll just create one table first of all, and then convert that table into the distribution. Okay, all right. So for example, I wanted to show that how many students there is, marks, range, and numbers of students. For example, from 0 to 50 out of 100, for example, we have around 20 people, 20 students. From 50 to 70, we have 40 students, and from 70 to 90 we have 10 students, and 90 to 99 we have, for example, 5 students. All right, so what I have to do is, if you can see, we have data in set format. In this first, we have set from 0 to 50. We have minimum range, we have maximum range, and then we have to represent data in that particular set. Then definitely we need to use this distribution format. Okay, all right, so let's move now to the definition. And first of all, how many distribution are there, how many types of distribution we have? So definitely we have 3 distribution. First one is frequency distribution. Second one we have is histogram distribution. Third, we have cumulative distribution. Okay, so this is these 3 types of distribution we have. We will see it one by one. Okay, we will see it one by one. So let's get started with the first one. What we have in first one. So let's see what is the frequency distribution. Okay, sorry. Okay, let's see what is the frequency distribution. The frequency of a value is the number of time it occur in the data set. Whatever I have told you about this set is nothing but data set. Data set have a kind of range in between, which have minimum and maximum capacity, minimum and maximum value. Okay, so in this scenario, for first one, we have data set from 0 to 50, and how many students are repetitively getting in this range is nothing but frequency distribution. Frequency, the pattern of frequency of the variable. Okay, so pattern, that means exactly how many students are been there for this set, data set from 0 to 50 mark of score. All right, so this is, if I want to represent it, then I can use this frequency distribution. Okay, how I can do that? We can do that in the representation form in histograms. Okay, let's quickly check what is the advantage we can have by using this frequency distribution. The distribution is presented in an organized, easy to represent format. So for example, now see, I want to represent this data, and you are actually using for example a bar chart. If you calculate here how many students are there, if you can see this, how many students are there, 40 plus 20, 60, 70, 75. You have to create bar for 75 students. This types of bar you have to do it for 75 times. Don't you think this is really difficult? Even it is difficult to read as well, and it is difficult to recreate the report as well, correct? I want to compress that complete bar chart into the smaller chart which can be understandable to everyone. Okay, so how I can do that? Simply I can convert that complete 75 bar in range format, and this is the advantage. I can represent that complete 75 student bar in just 4 rows. Again, if you want to see, if you want to highlight or integrate yourself in deep study, so then you can simply go in this data set and you can again start your analysis. Okay, if for example, if you have seen first time this 75 chart for 75 student, have you really feel it, you want to read that data? No, I don't think. Even it's not for me as well. It is really difficult to see 75 students data in graphical format. So if I represent this frequency distribution, then it will be really easy to understand the actual score capacity, and also we can say a talent version in talent student, the range of talent in the class. Okay, all right, this is one advantage. Second, we have the most frequency occurred scope are easy and identified. Like I said, it is very easy to represent. The scope ranges lower and upper limit cases are not been common. Outlier, as I say, it may change. Here I have taken a range for 50, here I have taken range for 20, here I again have taken range for 20, here just have taken the range for 9 range. So in that case we have different actual minimum lower value and upper value. It's depend on person who want to represent the data. So in this scenario, this is completely depend on me. Okay, all right, and the total numbers of observation between any of the scope that we can identify, like I said, we can simply identify how many students between 0 to 50, that is 20 students. All right, so this is the advantage. Let's see the next one. What we can have, the range of data can be determined easily. As I said, we can easily determine the data. It improve the accuracy and efficiency of the estimation. Okay, as I said, if we want to represent these data of 75 students, so this is we can do some actual improvement or we can see the actual accuracy in this kind of format. Okay, it helped to focus on important sub-pollution and ignore the irrelevant ones. Okay, so what I have to do is in the current example, if I want to do some extra training for the student, those getting less numbers of score. So in that scenario, what I can do, those student have less than 60 mark, I can, or those student who have greater than 60 marks, I do have different training for them. Those who have less than 60 marks, I'll simply can place them to different training. Okay, so this way I can manage or take the decision for the student. For example, in this scenario, as it is a class. Okay, see, here is the example, new example. How many student getting score from 1 to 10 is 9 student. How many student getting score between 11 to 20 is 17, 21 to 30 is 22, 35 to 60 is 40 is 18, 41 to 50 is 13, and likewise. So this way you can represent the data. Okay, for this frequency distribution, if you want to represent that data in graphical format, what we have next is histogram. Okay, so this histogram is nothing but whatever data we have in the frequency format, so we simply can represent that in graphical format. Okay, let's see the definition. Histogram is a graphical representation of the distribution of the data. It is represented by a set of rectangle or adjacent to each other, where each bar is represent a kind of data. Okay, so as I said in previous slide, where we are representing data in range format, if you can see here, this histogram have range. For example, in this scenario, it have 59 to 61, then 61 to 63. Here we have 63, 63, 64, 65, 66, 67. So whatever the data, if you can see here, it represents some data. If you can see, it represents some data. Okay, but what we have range is 59 to 61, 63, 65, 67. Okay, if simply you can convert this into the table, you will have some data. Okay, all right. So just for example, if I want to convert this, it is in tabular format. So what I can do, range and then height. 59 to 61 is have the height of 2. 61 to 63 have height of 1. 63 to 65 we have height of 5. Likewise 73, 75 we have height of 4. This is simply the tabular format data. We have converted that data into the histogram distribution format. All right. Okay, it is very easy. I don't think any complication or any difficulty you might feel to learn it. If you feel it anything, please write down in something in comment. If you need anything else, so I can give naive example, I can come up with some great solutions as well on it. All right, let's move ahead. What we have in cumulative data, as this is the third type of frequency distribution or kind of distribution. So what is specifically we have in this? Okay, so let's see. First we have learned is frequency distribution. Second we have learned is histogram distribution. Okay, and third one is we have learning it cumulative frequency. Okay, let's see what is the cumulative frequency is. Cumulative frequency is the sum of all the previous frequencies, okay, up to the current point. It is often referred as the running total of the frequency. What does mean it of? So for example, okay, for example, cumulative frequency we can call it as simply in form of summation of the previous frequencies. It mean if I represent the data from 0 to 15, so what it actually meaning, so it can count it as a 0 plus 34. I want to represent the data from 0 to 20, it will be 20 plus 34 plus 26. I want to represent the data from maybe 0 to 25. What I can do, I'll just add this. Okay, so if I want to represent the data from 0 to 25, what I can do, I just add between this. Okay, I will add all the ranges. After the adding the ranges, whatever value I'll get, so that value is nothing but cumulative frequency data. Okay, so again, this is extension or grouping of the frequency data. That's why we call it as cumulative frequency. We are not calling it as cumulative distribution directly. We are calling it as cumulative frequency. Okay, all right. So this is simply very simple example I have just given. So this cumulative, whenever you want to do some rounding, data rounding work, so in that time this cumulative frequency come in picture oftenly. Okay, all right. I hope this is understood to you guys. I don't think any difficulty here to understand. It is very simple, very easy to simply represent or understand the issue. In maybe next data science stream or in statistics session, I also write some comments in form of standard commands. From there you can simply create this all frequencies by yourself by simply putting the data. Okay, all right, thank you so much to be here and stay here for very long duration. I really appreciate your patience and thank you so much for being here. I request you to follow this website where we have all data available in form of notes. In some days we also publish our mobile app with the Arpan name. So there we have, you simply can install it from a Play Store. We have all data there. We have the application. In the application, everything whatever data you want, you will get it. All lectures you will get there, all notes and everything whatever interest you have in, definitely you can find out something out there. Okay, all right, thank you so much guys. Thanks for your patience, thanks for your support. I really appreciate that, and thank you. Keep smiling. Thank you so much.